This video is about drawing circuit symbols. So you're going to have to be able to, in this module, to build electric circuits, and you're going to have to be able to interpret those from circuit diagrams, and also once you've built a circuit, be able to convert it back into a circuit diagram. So the first thing that most circuits need is a power supply. So there's a couple of ways we can do that. We could have a cell to begin with. Now a cell is what you will think of as a battery. So if you think of an AA battery, that isn't really a battery at all. That is a cell. And a cell is a single battery, as you would conventionally think of it. Now, just to explain the difference, a battery we would draw like a cell, but we would have a dotted line and between the two cells. So a battery is two or more cells. So that's our definition of a battery. It's two or more cells. So a single battery, as you would effectively consider it, is actually called a cell. So we have the two lines, one longer than the other. The longer one always represents the positive terminal, and the shorter one represents the negative. The way that I remember that is I imagine that I can take the longer one, snap it in half, and make a little positive symbol with it. So we've got positive and negative. It's the same on a battery. So most circuits will have a power supply like so. Another way of doing it is just to show terminals. So sometimes in electric circuits we can be lazy. And sometimes we don't want to include the whole circuit. So we might include terminals, and what we might just put, just to be lazy, is we might say, well, there's 230 volts between here, so maybe that's been plugged into the mains or something like that. And we could there's a whole lot of information we could put about between these terminals, but just imagine that terminals are that the circuit is complete between those 2 points, but it's completed somewhere else, and we're not really interested in it, and it doesn't make a huge amount of difference to the circuit that we're analysing. So that's terminals. Now, the next type of component that's really key is meters. So we have a couple of different types of meters. We have an ammeter, which we use to measure current, and an ammeter which measures current, because obviously current is measured in amperes, has to be connected in series in a circuit. Okay. Now that is in contrast to a voltmeter, which we use to measure potential difference, or voltage, as you will know it at the moment, and that is always connected in parallel. Now the key is to understand why we have to connect these things, one in series, one in parallel, is down to the way that current and voltage work. So remember, current is the rate of flow of charge. So what an ammeter basically does is, you can imagine it like a person standing at the side of the road with a clipboard counting how many cars have gone past. So that's what an ammeter does. It stands literally at the side of the road, right, like in the circuit, by the road, and as the electrons travel through the ammeter, you can think of it as like counting them, like how many electrons have we had, how much charge have we had every second going past me. Voltage, on the other hand, because voltage is linked to energy, voltage has to be connected in parallel, so it has to be connected across a component, whatever that is. And the reason it does that is voltage is comparing the energy before and the energy after. It has to compare the difference, which is why we say that it measures potential difference. It compares the energy at the start, before the current has gone through the bulb, and then after. And obviously the current uses up some of its energy, or transfers its energy to the bulb in order for the bulb to light. So in comparison, you want to think of a voltage as more like two people standing at 2 points on a running race. One person is measuring how much energy the runner has at the start, and one person is measuring how much energy the runner has at the end, to think about how much energy has been transferred. And so that's how the role that voltage plays, and that's why it's connected in parallel. You can also have an ohm meter, which measures resistance directly, but it's very rare that we talk about an ohm meter. And a multimeter is a meter that can do all three of these things. It can measure current, voltage, and resistance. The next one that we usually have is we have components that we might want to use. So the symbol for a bulb is a circle with a cross in it. There are other symbols for a bulb sometimes used, but this is the most common one, and the one that I would encourage you to use. That's the symbol for a bulb. A motor is very, very straightforward. It's a circle with an M in it, so that's a motor. Another common component that you will have is a resistor. Now, resistors are important because they come in a whole variety of shapes and sizes. Now, you might think, why do I want to add a resistor? Why do I want to add resistance to a circuit? And actually, it's very important that we do, because all electrical circuits work on one basic idea, which is that electrical power is transferred from the power supply, which is the cell or the battery, to the components. But more importantly than that, the correct amount of power has to be transferred from the cell or battery to the component. If the battery, for example, has a really high voltage or EMF, and the bulb that I'm using only needs a very small voltage, if all of that energy is transferred to the bulb is likely to heat up and then blow, and so it'll be damaged. So I need to control how much current and how much voltage is going to each component to make sure that it works correctly. And so resistors play a really crucial role in that. So the basic symbol for a resistor is just a rectangle, and this is a fixed resistor. And what I mean by fixed is that it has a fixed value. So this might be a resistor that is 100 ohms, and it's always 100 ohms and it doesn't change. Now, we can also have what we call a variable resistor, which is a resistor that you can change the value of. Now, a variable resistor has another name that you should be aware of, which is a rheostat. And quite often it consists of a long coil of wire that you can move a slider up the wire to change the length of the wire and therefore change the resistance. But the way we show something as being variable is that we draw an arrow from bottom left to top right going straight through it. So I can also have what we call a variable power supply, which I'm just going to include down here. So you draw a bulb, sorry, not a bulb, a battery, and then you draw an arrow through it to show that you can, rather than it being a fixed battery, like maybe something always 6 volts, for example, you can increase it, like a bit like a power pack. So a variable power supply, we draw like that. So variable is this arrow going straight through. Now there are several other types of components based on this shape of a resistor. One is when we keep the line going straight through, and this represents a fuse. And obviously fuses are designed to protect electrical components, just like a resistor. And if the current gets too high, this piece of wire in the center of the fuse will melt, the circuit will break, and it will stop working to protect the components. Another one is that when energy is transferred to a resistor, it's all transferred as heat. So a heater is also drawn in a very similar way to a resistor, but it has lines going down, so that would be a symbol for a heater. Now, some resistors depend on certain conditions. So one of the most important ones is light. So if you have light coming into a resistor and it's affected, so we call this a light dependent resistor, or an LDR for short. And it's important to remember that with a light-dependent resistor, the relationship is slightly unusual, and it's always remember it's the opposite. So as light intensity, measured in lux, increases, the resistance decreases. So it does the opposite. So if you've got a lot of light, the resistance is very low. If you've not got very much, the resistance is very high. We also use this same shape in another component, but it depends on temperature, which is called a thermistor. And that looks like a basic fixed resistor, but with like a hockey stick through it. So we call this a thermistor. And obviously this depends on temperature. And just like an LDR, it's the opposite. So as temperature increases, the resistance decreases. So it's just these two components where we have this opposite relationship, but it's important that we remember these two. And these are both examples of what we call semiconductors. So they're both materials made out of semiconductors. And as light intensity goes up, resistance goes down. And as temperature goes up, resistance goes down, or vice versa. Now, a couple of other components that we need to be aware of. One really important one is a diode. Now, a diode only allows current to flow in one direction. It's a little bit like a traffic warden that says you can only go this way, please. And so the way that we show which way it can go, which way it's biased, is by the direction of this triangle. So in this case, it's biased in this direction, so we describe it as forward bias. So current can only flow that way, but can't flow that way. And the implications for that we will look at a later stage. Now, there's a type of diode that you will probably be familiar with without realizing it, because this is a diode that emits light. And you'll notice that over here where light comes into a component, it comes in at the top left. But when it's emitted, when it comes out at the top right. This is called an LED, which is short for a light emitting diode, and you're most likely to have heard of an LED from LED TVs or LEDs on like Christmas lights or those kind of things. And again, that only allows current to flow in one direction, but crucially, it also emits light at the same time. Now, this is the vast majority of circuit symbols that you will ever encounter. There are others, but if you use these, you will be able to deal with most of the basic circuits that you'll be faced with. One that's occasionally talked about is buzzers. Buzzer is just a circuit with an M in it, but you can also have the circuit symbol for a loudspeaker, which is slightly different, which looks like this. So this would be a speaker of some description. So something that's, instead of emitting light, would emit sound. But these are your basic circuit symbols, so you do have to learn these. So make sure that you practice them. Do look, cover, test, check, cover them up, try and practice remembering them, see how many you can draw in a minute and remember, then test yourself.